Our universe is a brilliant tapestry, woven from 1 trillion galaxies, each one packed with billions of stars. But what if I told you there's a place where this cosmic light just goes out? A region of space so enormous it could swallow thousands of our own Milky Way galaxy. But instead, there's almost nothing there. This is the story of the Boötes Void, a cosmic desert so vast and empty it challenges our very understanding of how the universe is put together. Back in 1981, a team of astronomers led by Robert Kirshner was doing something revolutionary for the time, making a 3D map of the universe. By measuring the redshift of galaxies, a clever trick that uses the stretching of light to figure out a galaxy's distance and speed, they were piecing together the grand structure of the cosmos. As they pointed their telescopes toward the constellation Boötes, the herdsman, they expected to find what they'd found everywhere else, a pretty steady and predictable spread of galaxies. But they didn't. As the data rolled in, a picture of something deeply weird began to take shape. There was a gap, an enormous, almost spherical region where the galaxies just stopped. At first, they thought it had to be a mistake, maybe a glitch in the data. But as they surveyed more and more of the sky, the emptiness was confirmed. They had stumbled upon a void of almost unimaginable size, which they nicknamed the Great Nothing, a name that perfectly captures the baffling emptiness they had found. What they had discovered wasn't a hole in space, but a hole in the distribution of matter in space. A cosmic desert where there should have been an oasis of light. This discovery was a turning point, revealing that the universe's structure was far stranger and more extreme than anyone had ever imagined. It's one thing to say the Boötes Void is big, but it's another thing to truly wrap your head around its scale. This void is located about 700 million light-years from Earth and is a roughly spherical area of space. Its diameter is estimated to be a staggering 330 million light-years. To put that into perspective, our own Milky Way galaxy, with its hundreds of billions of stars, is about 100,000 light-years across. That means you could line up more than 3,000 Milky Ways side by side just to cross the Boötes Void. Based on how packed together galaxies are elsewhere in the universe, a region this huge should contain at least 2,000 galaxies, maybe even as many as 10,000. So far, astronomers have found only about 60. And here's where the scale gets truly mind-bending. The astronomer Greg Aldering once said that if the Milky Way had been in the center of the Boötes Void, we wouldn't have known other galaxies even existed until the 1960 seconds. Let that sink in. For almost all of human history, our view of the night sky would have ended at the edge of our own galaxy. The groundbreaking discovery by Edwin Hubble in the 1920 seconds that other island universes existed beyond us might have been delayed by decades, all because of the sheer isolating emptiness. Our sky would have been a canvas of near-total blackness, a constant reminder of an almost unimaginable solitude. So, how does the universe create such a massive pocket of emptiness? It seems to fly in the face of logic, but the existence of the Boötes Void, as shocking as it is, actually fits perfectly with our leading model of the universe's large-scale structure. Imagine zooming way out, far beyond our galaxy and even our local supercluster, until you can see the entire observable universe. You wouldn't see a random confetti toss of galaxies. You'd see a magnificent web-like pattern. This is known as the cosmic web. It's made of long, thread-like structures called filaments, where galaxies and galaxy clusters are strung together like pearls on a necklace. At the intersections of these filaments are the great cosmic cities, massive superclusters. And in between all of that, that's where you find the voids. This cosmic architecture is a direct consequence of the Big Bang. In the first moments of the universe, everything was an incredibly dense, hot soup of matter and energy. It was almost perfectly uniform, but, and this is the important part, not quite. There were tiny, random quantum fluctuations. Some spots were just a little denser than others. Over billions of years, gravity got to work. The slightly denser regions had more pull, so they started grabbing matter from their surroundings in a cosmic snowball effect. The rich got richer, pulling in gas and dust to form stars, galaxies, and eventually, the massive filaments and superclusters we see today. But as these regions grew, the areas they pulled matter from became emptier and emptier. These less dense regions expanded, creating huge pockets of nearly nothing. The leading theory for how the Boötes Void got so enormous is that it's the result of smaller voids merging over billions of years. Think of soap bubbles in a sink. Over time, smaller bubbles pop and merge to form bigger and bigger ones. The Boötes Void is thought to have formed in a similar way. This process gets a turbo boost from dark energy, the mysterious force causing the universe's expansion to speed up, stretching the voids even larger and making the filaments stand out even more. While the Boötes Void is famous for its emptiness, it's not entirely empty. The 60 or so galaxies that have been found inside it are some of the most isolated objects in the entire universe. And they aren't just scattered randomly. Most of them are lined up in a strange, tube-shaped region that runs right through the middle of the void. This cosmic tube is thought to be a kind of fossil, a ghostly remnant of the boundary between the smaller voids that merged to create this supervoid. Life for these galaxies is profoundly different from our own. Here in the Milky Way, we're part of the local group, surrounded by dozens of cosmic neighbors. We're constantly interacting with them and are even on a collision course with our biggest neighbor, Andromeda. But the void galaxies are adrift in an ocean of darkness. One of the most famous residents of this emptiness is a spiral galaxy with the very unpoetic name MCG plus 01020015. The European Space Agency once called it the loneliest of galaxies. It's a beautiful spiral, a lot like our own Milky Way, but it seems to have spent most of its life in solitary confinement. Its very existence raises some cool questions. How does a galaxy form and evolve in such an extreme, low-density environment? Without the gravitational nudges and smash-ups that are common in crowded filaments, these void galaxies might be some of the most pristine examples of galactic evolution in the universe, developing in almost total isolation. For any hypothetical civilization inside one of these galaxies, their idea of the universe would be totally different. Their night sky would be almost completely black, with none of the faint smudges of distant galaxies we can see. Discovering other galaxies and with them, the expanding universe and the Big Bang would have been an almost impossible challenge, demanding technology far beyond what humanity needed in the 1920 seconds. They'd live in a universe that, for all they knew, was just them, alone. The Boötes Void is way more than just a cosmic curiosity. It's a critical piece of the puzzle for understanding our universe. It shows us that the grandest structures in the cosmos aren't just the bright clusters of galaxies, but also the vast, dark voids between them. In fact, voids aren't the exception, they're the rule. Astronomers estimate that voids take up about 80% of the volume of the observable universe. Statistically speaking, most of space is empty. Studying the Boötes Void and its few lonely residents helps cosmologists stress test their models of the universe's evolution. The void's sheer size pushes the limits of what our current models predict, forcing scientists to get a better handle on how gravity, dark matter, and dark energy all work together to sculpt the cosmos. And the galaxies inside it act as unique laboratories, offering a peek into how galaxies might grow up without the constant interference of neighbors. The void is also a powerful illustration of the forces that are shaping our universe's ultimate destiny. The cosmic tug-of-war between gravity pulling matter together into filaments and dark energy pushing everything apart and making the voids bigger is the engine of cosmic evolution. The Boötes Void is a spectacular monument to the power of that expansion and emptiness. From an accidental discovery in a galactic survey to a cornerstone of modern cosmology, the Boötes Void has completely changed how we see the universe. It's a place of profound emptiness, a cosmic desert 330 million light-years across, where thousands of galaxies should be, but only a handful exist. It was likely born from smaller voids merging together, a process driven by gravity and supercharged by dark energy, leaving behind a giant scar of nothingness in the cosmic web. The Great Nothing is a humbling reminder that the universe is shaped as much by its vast, silent darkness as it is by its brilliant clusters of light. It's not just an empty space. It's a space filled with questions about our cosmic origins and our ultimate fate. It shows us that even in the most desolate corners of the cosmos, there are incredible stories waiting to be told, and that sometimes the biggest discoveries come from understanding the nature of nothing at all. If you enjoyed exploring this colossal cosmic mystery, give this video a like and subscribe for more journeys into the most fascinating corners of our universe. What's the most mind-bending fact you've ever learned about space? Let us know in the comments below. Thanks for watching.